Hello everyone. In this video, I'm going to demonstrate how the Perseus work. So Perseus is one of many topological data analysis packages. Perseus is fairly simple to install and it's fairly easy to use. Okay? So if you'd like to know more about other packages, please talk to one of us. We will be happy to show you around. Okay? All right, so here is a rundown of this very brief Perseus tutorial. First, we will go over the prerequisite file I sent you earlier. Second, I will show you how to find Perseus and how to download Perseus. Third, I will show you how it works, how Perseus works in the terminal. So if you are never deal with terminal, don't worry. We create a simple interface in MATLAB and that will help us reduce the technical barrier. And finally, I will show you how to calculate a persistent diagram of a grayscale image. And you want to make sure your output is the same as mine so that you know your result is correct. Okay. All right, so let's jump into it. The first thing I would like you to look at the file I sent you. It is a zip file. So please unzip that file. Once you unzip that file, you should see a directory, okay, called TDA working. So in this directory, there are 6 files, 4 images, and 2 MATLAB files. And I will explain more about those MATLAB files. And second, let's take a look how do we find Perseus and how do we download this Perseus. So go to any browser, any search engine you like. You can type Perseus and then homology, that's a keyword. That should lead you to the page. Perseus, the persistent homology software. That's the one. You click it, go through this page, we need to download or compile. Okay? So if you are familiar with C++ or any compiling language, you could download the source code and then compile on your own machine. Okay? So here are very straightforward guideline or steps provided by the author. On the other hand, if you are not familiar with that process, don't worry, because author provides the executable file. So all you need to do is to download this suitable executable file based on your system. Windows, download here. Linux, download here. Mac, download here. Because this machine is a Mac, so I'm going to demonstrate this entire process on the Mac machine. All right, so that's the file is download. Once you download that file, what I want you to do is to copy this file and paste it to the TDA working directory I shared with you earlier. Okay. Once you have done this, then what I want you to do is go to the terminal, right, with respect to this directory. So I already have this terminal open. Okay, so you can look at how many files. Make sure you are in this right position, and to execute this file. Right, so this is the thing you need to know about the executable file. Unlike any other application, maybe like a Chrome or Safari, any other application, what you need to do is just click that icon and everything will work. Okay. In executable file, you need to type the command. All right. So the command to execute this file is /Perseus Mac. Okay, So we hit this and you should see an arrow. Right? This is a very common error because your system is trying to protect you. So that's why you have a permission denied. So to resolve this problem, what you need to do is type this command chmod plus x and Perseus, okay, that file. So that will give this file a permission to run in this machine. Sorry, give this file permission to run in this machine. Okay. All right. So as I hit enter, you should see this changes to this executable file. So now what I want you to do is to type this file again, /Perseus Mac. Right? So that means you are successfully run the Perseus, right? Even though that tells you incorrect number of arguments, but that means you successfully execute this file. Okay. But this doesn't mean you are calculating anything, right? So in order to properly run Perseus, what you need to do is to follow the instruction from the Perseus web page. Okay, so if we go back to the web page, there is some basic information and the usage, persistent homology of the cubical complexes, and the persistent homology of simplicial complexes, and so on. In our case, in the most of your projects, we will be using the cubical complexes. So you can click on the cubical complexes tab. So it will show you the details how you can use this software. In other words, how do we specify all the arguments and how to specify the input file name. Okay, so that's how it will work. But as you can see, it is a fairly tedious process. So in order to reduce this technical barrier, so we create a MATLAB interface so that this interface deal with all this technical issue. You can simply type something and then run Perseus. Okay, so that's why I want you to go to the directory I shared with you earlier. Okay, click on Run Perseus. So that should open up a MATLAB file. So here is the Run Perseus file. Okay, and please make sure in the MATLAB you are under the directory. This is the current folder. That's the folder that contains Perseus and the Run Perseus and all other images. Okay. Okay. Once you do that, then what you need to do is the following. So this file transform everything in one simple command. So you can execute this file and you will run Perseus properly. Okay. So one thing to change is based on your system. If you are a Mac person, you can see this is /Perseus. So here we're trying to implement or execute Perseus in command line. But notice my file name is Perseus Mac, so you may want to change this to Mac here. Okay. I think if you are a Windows machine, this file will be Perseus Win, and that's change it based on your file name. Okay. Once you have this, then everything should work. Okay. So what do I mean everything works? So the first thing I want you to do is read in this image. Okay, so this image, let's say the image of this, right? This is a part image. So how do we read in the image from MATLAB, right? So you can do the following. A equal to imRead. So imRead is a built-in function in MATLAB that will read an image into MATLAB and that will store in a matrix. Okay, oops. Part. All right, now you can IAmShow, that's another built-in function in MATLAB that will show you what this matrix will look like. So if I do that, so you can see that's the image, right? That's the image you can have. So how do we run Perseus of this image, right? How do we run Perseus? So now we have this file, run Perseus. So what I do is run Perseus. Okay, so that's the file. Make sure this command line is that same thing here. And the first argument will be the file name, right? So this will be the output file name. You can type whatever you like, okay? So I will type whatever I like. So I would just type my name, or type my name, okay? And the second argument here, the mat. So that mat will be your image, right? So this is my image. Dimension. So this is a two-dimensional image, right? 128 by 128. It is a two-dimensional image, XY. So the third argument will be 2. Okay. Once you do that, you hit enter. So now you can see the process run successfully, right? So this is the message coming from Perseus. Okay, so that's how you read from some burst time and then done. Please consult this for result, right? Notice this CHUNG is user defined. You can just type whatever you like. Okay, so now all the computation is done. The result is stored in CHUNG .txt. So Perseus will create 1, 2, 3, 4 files. Okay, good. And now to visualize this thing, to visualize this result, what I want you to do is type Perseus, right? So that's the file we have in the TDA working, right? So that's the file we are going to call. So Perseus, and then you do CHUNG underscore 0.txt. So I'm looking, so this file means I'm going to visualize the output, right? And what is my output file? I'm going to look at the 0. Okay. So that will show you this is called the persistent diagram of that image. Okay. And the 0 means the 0th dimension, right? So this is the 0th dimension persistent diagram. Now, if you want to look at the first dimension, you can type a 1 there. So that will show you the first dimension persistent diagram. Okay, good. So let me plot this one more time. Plot this. This is the 0th dimensional persistent diagram. And plot 1. This will be the first dimensional persistent diagram. Okay. So please make sure if you follow everything we've done so far, those two images or those two results is what you should got too. So make sure you follow everything and make sure you got those two persistent diagram. Okay. I hope this is helpful. If you have any question, feel free to email me.